Hi there, and thank you for joining us for a discussion on a 2035 vision for air traffic services. My name is Emily Stelzer. I'm the manager for NAS Future Vision and Research at the MITRE Corporation's Center for Advanced Aviation System Development, the FAA's federally funded Research and Development Center, or FFRDC. We have worked with the FAA for over 60 years, providing technical expertise in air traffic management systems engineering, aviation operations, airspace design, and systems automation and integration. Today, I'm really excited to be here with our guest, Mr. Steve Bradford, the FAA's Chief Scientist for Architecture and Next Gen Development with the FAA's Office of Next Gen. Steve has been one of the driving forces in the FAA's Next Gen program. Welcome, Steve.
Thank you.
Recently, you had asked the MITRE Corporation to work with you in defining a future vision for air traffic services within the National Airspace System. Could you share why now is the right time to begin planning for that future?
Yeah, I think the most important thing is that we were realizing that we were doing it already. We just needed the context for it because the last couple of years we've spent a lot of time on new entrants, a lot of time on internet and IP, and a lot of time on trust frameworks, a lot of time on everything other than trajectory-based operations, which was kind of reaching its maturity. So we said, you know, we need a new vision for the future, what the to be shall be. And that's why I said it's time for us not to just look at the next incremental step, but to kind of lean out there 10, 15 years and say, where should we be?
The future vision is really looking at those kinds of innovations and how they apply to operations, infrastructure, and safety. So why don't we dive in on the operations topic first?
Okay.
The past decades have seen a phenomenal increase in information connectivity across all kinds of industries. Can you help describe why the aviation industry, including ATM, will need to embrace that information revolution in order to support safe and efficient operations?
Yeah, I think the key thing is that we've gone as far as we can with our current form of communications, which is basically voice, with occasional messaging, 20 minutes, 30 minutes, 40 minutes ahead of time. In this world where you can make more minute adjustments, where machines can help you make those adjustments, you really do need to embrace the information. Up until now, and even probably going into the future, all the decisions have been really being made by the brain and the voice put together, and what we're looking at is really cognitive support for those operations and really supporting individual operators. Now, I don't think manned aviation will change that quickly. I mean, we have aircraft that last 30 years. We have pilots who talk to controllers, but you don't really have the same environment with small UAS where an operator may run 10, 15, 20 vehicles at the same time. In that regime, you don't make it up all in your head, and you don't do all the communications with voice. And I think this is why now we need to embrace the information age.
So are we learning things from those new entrants as we think about how they could apply to these other operations?
Yeah, I really do. I think that we're learning that it's not hard to do information in this new environment. Every other industry has managed to do it. Sometimes aviation feels like it's really, really special. And we were for many, many years. Now it's time for aviation to realize that there's a lot of things going on around us that we can adopt. We see some of even the big airframers looking at autonomous aircraft. Well, you're not going to fly autonomous aircraft with a handheld control and somebody sitting in a basement. You really need to do that with digital information and the machine supporting you.
So Steve, you spoke about sort of this emergence of new vehicles performing new missions and operating in new ways in the airspace. The growing number of airspace users is likely going to cause greater competition for access to that airspace. So how will the FAA's future vision address this issue of access?
I think that one of the big misnomers is that there's no airspace out there. There's lots and lots of airspace. Yeah, if you want to get to the big airport and next to the big runway, then there's probably an access issue. But with tailored flight rules and different airspace structures, we can actually accommodate lots and lots of vehicles. We've been doing this with a small UAS where they fly 400 feet below. We establish the rules by which they behave. but we don't actually offer any air traffic services. So the key is the rules there are for the small UAS. We can do the same thing in lots of other airspace. There's lots and lots of places in the United States where if you stay below the 3-degree glide slope at the airport, you can fly around. We've been doing this for years with general aviation and VFR flight, where they go out, they fly, they follow the rules of the road, and they don't have to talk to air traffic. So if you want to get into the airport and you want to get down to the runway, we can integrate you. But you'll have to talk to the air traffic controller. You'll have to take your turn. We're not going to add thousands of new controllers, and so there'll be some demand capacity balancing. If you're willing to get to the parking garage outside the airport, I could probably get you in and out of there without ever letting an air traffic controller know that you're there. So that's what the future vision talks about. New tailored flight rules, new tailored airspace designs, so that we can accommodate you without having to totally integrate you into air traffic control.
So let's turn now to how we see infrastructure changing. The growth of air vehicles will impact not only airspace access, as you discussed, but may also stress the infrastructure of the NAS. How is the FAA exploiting commercial technologies to provide a solution to this future need?
Well, in fact, we don't want it to stress the NAS infrastructure. We're looking at, in most types of operations, unless you're talking to a controller, we don't want you on our frequencies. We don't want you using our spectrum. With a small UAS, they'll do a combination of cellular phones or satellite outside of our communications. We don't need to see you if we're not providing air traffic services, so we don't have to worry about, can we pick you up on the radar? If you look at our remote ID rule, we're saying, you know, if you're flying 400 feet below, we don't want you squawking ADS-B. We don't want to have to filter you out. We'll come up with a different scheme for you to tell other people that you're there, but we don't need to see you in ATC. So further, we don't want you to follow a flight plan. If you're not flying with air traffic controllers, I don't want you to follow a flight plan. So what we're doing is we're going, okay, previous question about the tailored flight rules. We're also tailoring the infrastructure. Okay, I don't want you in my infrastructure, so what do you do then? You turn to third parties, and third parties can provide the internet backup. They can support you in sharing your position with other people. They can support you in your communications. And so we're looking at qualifying third parties to provide basic infrastructure services to the other entrants.
If we look though to that 2035 timeframe, the traditional systems of the NAS, things like ERAM, STARS, they're going to be reaching an end of life or sort of a need to sort of continue to modernize those systems. So what steps will be taken to accelerate the transformation of those monolithic systems, the ones we have today, to a future where we have more flexible systems or services that could be implemented more quickly? And will private industry play a role sort of in that evolution or process?
A little of both. I think the most important thing to realize is that we incrementally built those systems up from a lot of little services. We like the idea of having a mainframe, but we didn't want multiple mainframes. So we said, let's put all the software on the same mainframe. And oh, by the way, since it's there, let's reduce our risk and let's integrate it all together. So if you look at ERAM, it provides a surveillance data processing service, a flight data processing service. It does a coordination with the terminals, et cetera. Do you actually have to build it that way again? And the answer is no. Well, how do you build out of that then? Well, you look at those opportunities where you're sharing information already for like flight data between the user and the TFMS system, or the TBFM, the time-based flow management system, and the controller or someone else. You can start building around our big systems, improving the access to information, and slowly build an infrastructure on the outside that lets you hollow out the inside. A good example is in Charlotte. We've been doing a demonstration, and we're doing two things in Charlotte. One, we're demonstrating how business jets in higher end general aviation can provide what we call the 9 data elements for strategic flow on the surface to us via iPads, cloud, and into our infrastructure. That's really good. And now I haven't had to go through my TFMS system and my major AOC systems. I'm beginning to do a convenient internet-based way of providing new information. Another thing I'm really excited about, we've been working with MITRE on, has been the delivery of pre-departure clearances to general aviation, where we can take the flight information that's coming out of ERAM and providing it directly to the user on his iPhone or his iPad. And we can do that without actually having to touch ERAM at all, using SWIM and a couple other characteristics. Now, we do have to add one more data field because we didn't ask ERAM to give it to us in the first place, but that's just another piece of sharing information. So there are ways we can build around without having to go inside and tear something out. We can just build around it and let it wither away. And that's my goal. ERAM will wither away. Probably in 2040.
This sounds like exciting opportunities and research that's going on. Will that transformation still maintain the safe and secure system that the FAA has built today? Are those still sort of core priorities?
Everything is performance-based. So we have, which most people don't think about, is that our systems aren't safe in our NASA requirements. It's the information that has performance on it. So we can have performance on the latency, reliability, security, and it's on the information. And we actually can do a better job of building that into our systems as we go forward, and we worry about the information, the performance of the information. ERAM is a safety critical system, but not all of ERAM, just some of the information. We have performance on each bit of information. And so we can build systems, we can test systems that meet our performance requirements. Even if I decompose a big system like ERAM, I will have a safety core, a safety critical core, that final separation core, and we'll maintain that very rigorously and very carefully, and we'll look at the information going out, in and out. But a time schedule for a fix in order to do efficient flow, not the same level of performance and requirement, and we'll tailor it to each little operation.
Let's dive a little more into safety then. With the growth of the data being available and sort of this influx of smart systems and things like machine learning and artificial intelligence, we expect that adaptive systems will play a role in the future in the NASA as well. So how do you see these systems being certified for use, particularly in real-time safety operations?
Well, I think we touched that a little bit just previously, is that you have to ask what's the use of the system. And then you could say what the performance of the system has to be. Like I said before, we probably aren't going to touch our safety critical systems every week or every night. But we could touch our traffic flow systems weekly, monthly, as we learn and grow, so they can adapt, because the criticality of the information is not so high that we have to be a priori be really, really careful. We'll have mitigations, etc. It's one of the big things that we have to work on the next couple of years. The aircraft people are working on it already. So, what do you have to secure? What level of performance do you need on an autonomous system, and then supporting systems? How do you certify them? We all see the Tesla, which can change the software every night. We're kind of going, well, maybe that's not exactly where we want to be, but we need to have some of those flexibilities built in. So I think there'll be patterns that we have, testing, and a good partitioning of performance that allow us to do this.
I think one thing that's clear is that the pace of innovation and change is really just continuing to accelerate, and the NASA will be no exception to that. Do you see the agency enabling the development and deployment of those innovative technologies within the NASA, and kind of what processes or new methods will be in place to enable that?
We already are. Now, once again, we're talking about those systems that don't have the same level of performance from a safety perspective. If you look at what we're doing, my favorite is the offshore precipitation capability, which we built with Lincoln Labs, and it basically takes satellite imagery and lightning imagery, and it builds what looks like a radar picture of storms over the Bahamas and out beyond where our radars reach, and it provides additional information to controllers and pilots about where it might be safe, not safe to fly, so they can do better planning. One of the things people forget is that the FAA doesn't separate aircraft from weather, but we do provide advisories on where you might not want to fly.
Right.
We see that capability growing. It's amazingly enough, it's not housed in one of our big, massive weather systems. So I think that what you're going to see is we'll have individual systems built in the cloud, providing individual advisory information, which we can machine learn and improve all the time. You don't have to go after one of my big processors sitting someplace in order to do this.
Right.
My big processors.
Are there other examples of work that the agency is doing now that you'd like to share that are sort of serving as pathfinders for the future vision?
Well, I mentioned one before. I really think that our work with iPads and iPhones, or I should say tablets and smartphones, let's not be Apple specific here, for delivery of flight plans to pilots. I think that's leading a way towards what I call democratizing aviation. We have a datacom which provides pre-departure clearances, push-to-load kind of things to 5,000 aircraft at 62 locations. Can I provide something that's not quite so safety critical, but makes it easier for a controller in a small tower and a pilot to get a clearance and to fly? Yeah, and if I can do that, then I really am breaking down some of those barriers that make it difficult for both GA pilots and towers to interact. The other thing we're doing is we're looking at, do I need to have a massive automation system in a tower in order to provide additional clearances, or what we call approval requests for departure? No, I think not. I think we can do that with using cloud and iPads and capabilities in towers. We can support a pilot leaving Traverse City going to O'Hare. We can make it easier for him to depart and get to O'Hare. Amazingly enough, it's never a problem getting to Traverse City from a demand perspective, but it's often a hard time getting from Traverse City to Chicago from a demand perspective. And being able to do that at other than my major airports is really important. So I think that effort where we're what I call democratizing aviation is real important. And it really does leverage internet, tablets, and all that information. You know, it's kind of like, I look back and I've been around for a while. I used to fly occasionally before 9/11. You used to be able to fly on the flight deck. And pilots were always replacing the pages in what they call their Jeppesen charts, their charts of all the approaches and everything else. Every 56 days, they get another stack of paper. You don't see pilots dragging charts around anymore.
That's right, you do not.
It's all on their tablets.
Yeah.
Of course, we're not allowed to charge for the digital data. We used to make money on the paper data. Oh.
Right. So this sort of future that you've been describing is sounds really exciting. Where can people learn more about this future vision?
Well, I think they can learn here at the conference that we're both going to attend. We also have a future vision document, which is a little bit higher level. We're working right now. Should come out either in the fall or just after January. By February, we should have updated our architecture to really reflect this new 2B environment. And so just stay tuned. This is probably the biggest coming out party for this future vision, and we plan on doing it continuously from now forward.
But the days and the years ahead have a lot of exciting opportunities, and we're really proud to work with you and the rest of the FAA on the vision and making it a reality. So thank you very much for your time today. It was my pleasure to speak with you.
It's always my pleasure to speak with you, Dr. Emily.